Brownian motion was first observed soon after the invention of the microscope, when everything was being examined under the microscope. In 1785, Ingelhaus observed the stochastic motion of pollen in water. Before we knew the existence of molecules, fantastical mechanisms were invoked to explain this behavior. Now we know better. The stochastic motion of the pollen is the result of collisions with water molecules. This type of stochastic motion abounds in nature. And in the next slide, I want to show you a few basic examples. First of all, stock market fluctuations. The stock market rises and falls and sometimes crashes, as in 2009, and the underlying motion of the S&P index appears to follow a type of random walk motion. Another example is the diffusion of food coloring in water. Take an ink dropper and drop a drop of food coloring in a beaker of water, and you'll see it slowly spread out. The way that it spreads out is governed by diffusion. Another example is the cultural diffusion of practices across different civilizations. And finally, diffusion of fluid through some porous medium, such as water flowing through a porous rock. If we want to understand all these phenomena, we need to have a good model. The many-body problem of pollen being buffeted by water is much too complicated to treat analytically. To make progress, therefore, we need to simplify. This leads us to the random walk model, which follows Einstein's very famous dictum that a model should be as simple as possible, but no simpler. In the random walk model, we disregard all the collisions between the particle and the external world, and instead posit that the random motion of the particle arises intrinsically from its own internal degrees of freedom. Pictorially, the particle may be replaced by a drunkard whose successive steps are in random direction because of his inebriation. This is the random walk model.